Hi, this is your video about chemical reactions. And so what we're going to talk about today is how you know whether a chemical reaction's happened, and we're also going to start introducing the idea of balancing chemical reactions. So chemical reaction is just a chemical change, and we talked about that a long time ago when we talked about physical changes and chemical changes. And so you're trying to take one substance and turn it into something else. So how do you know when a chemical reaction's taken place? You know when you have a temperature change. So you can either have a release of energy where something gets hot. A fire is a really good example of this, and we call that an exothermic reaction. Endothermic reactions absorb energy. So those are like the cold packs that a lot of coaches will have in their first aid kits. You will have to hit it, and then it breaks a clear plastic barrier, and that actually causes two chemicals to mix and give you your cold endothermic reaction. So it works like ice without having to have ice on hand. Color change is a really good example. Like this one down here, you can see the yellow showing up, but you have to be careful that not all chemical changes will have color changes, and not all color changes are chemical reactions. So be careful with that one. An odor change, when you'll get a smell, burning tends to give different smells. Gas bubbles, you'll see this whenever you open up a can or a bottle of pop. You'll start to see gas bubbles form, and that's from a decomposition of carbonic acid that's in the soda pop that gives you the CO2 carbonated beverage bubbles. And then a precipitate is a solid that appears during a reaction, and then down here this yellow one, you can kind of see that this is cloudy, and that is a solid, and eventually if this is allowed to sit long enough, that solid will fall to the bottom of the beaker, and you'll actually be able to collect it. And that's a solid that appears when you add two liquids together. Okay? You also can have reactants and products in your chemical reaction. So reactants are your starting substances. Think of them like the ingredients when you're making food, and they are always found on the left side of the arrow. Your products are the substances that you make, and they will always be on the right side of your arrow. In chemical reactions, there are different symbols that we need to be aware of. There is the plus sign. We say and in chemistry. We don't say plus when we put two things together. And the job of that is to separate two chemical substances if they're on the same side of the arrow. And the arrow's job is to separate the reactants and products. We call it yields. So we don't say arrow, we say yields. You also have what we call state symbols. And so if you see this symbol behind a chemical formula, that means that it's in the solid state of matter. L is for liquid, G is for gas, AQ is for aqueous, which means dissolved in water. And those are very helpful for knowing where chemicals are stored or how chemicals are stored in chemical reactions when you're trying to find something. The law of conservation of mass says that mass cannot be created or destroyed in a chemical reaction. So what that means is that if you start out with a certain number of atoms on your reactant side, you have to end up with that same number of atoms on your product side. So that is why we do things like balance reactions. And so your steps to balancing your reaction is you are going to count the number of each type of element for the reactants. And we are going to use subscripts for that. Subscripts are the numbers that you put in for the formulas, and those subscripts tell you how many of everything you have. If the number is 1, then you won't see a number written there, because remember, we don't write ones most of the time. Then you do the same thing on the product side. You will change the number of molecules to get the number of atoms even on each side, and you do that by adding a coefficient to the front of your molecule, and that tells you how many molecules you actually have. Now note, you can change how many molecules that you have, but you cannot change what they are, so you can't change the subscripts. Okay? So over here, I can't take away this 2 or take away this 2. They have to stay there because that's how the formula is written. You change this formula and you change what the substance is. And then the last thing you need to do is go back and check your work. Make sure that you have the same number of each element on each side, because sometimes when you fix one element, you'll find yourself messing up another element. So we're going to start off with our reaction to make water. So hydrogen gas and oxygen gas yields water is how you would read that. So I'm going to start out by making really quick drawings of what these molecules look like. So there's a 2 here, so I'm going to draw 2 H's. There's a 2 behind the O, so I'm going to draw 2 O's. There's a 2 behind the H, and nothing behind the O means there's only 1, so I'm going to draw my 2 H's with my O there in the middle. So it's a very, very quick, rough Lewis structure. We don't so much care about getting everything in the right place, we just want to make sure that we have something to look at. So when you're looking at this, you have 2 hydrogens on your reactant side. When you go over to your product side, you still have 2 hydrogens. That's good. That means you have not created or destroyed any hydrogen atoms. Right here, you have 2 oxygen atoms on your reactant side, but you only have 1 on your product side, and that's not good because that means that you have destroyed one of these atoms of oxygen to get from the front of your reaction to the back of your reaction. So we need to have another water molecule back here. That will get us 2 oxygens, but when I added more oxygen over here, I had to add the whole water molecule. So that gave me 2 more hydrogen atoms, which now means that I am creating 2 hydrogen atoms from the start of my reaction to the end of my reaction. So I'm going to add another molecule of hydrogen. So that will give me 4 hydrogens on both my reactants and product side, 2 oxygens on my reactant side, and 2 oxygens on my product side. So at the end, I go through, and you see these little lines in front of my formulas? I put how many molecules I wrote in there. You'll notice that right here is blank, and it's blank because I never ever write the number 1. So my next chemical reaction is barium carbonate yields barium oxide and carbon dioxide. So I have my quick, rough Lewis structures drawn. On my reactant side, I have 1 Ba. On my product side, I have 1 Ba. On my reactant side, I have 1 carbon. On my product side, I have 1 carbon. On my reactant side, I have 3 oxygens. On my product side, I have 1 plus 2 is 3 oxygens. So everything's okay. When that happens, and I go back to write my coefficients in, the numbers that go in front of here, there would be a 1, and a 1. But since I don't write ones, this is going to look blank. So I write a B, or I can write out the word balanced back here. That is so that Mrs. Miner knows that you balanced this reaction and you know that you didn't have to put any coefficients in and not that you just left it blank. Okay, one more example. Do my really quick rough Lewis structures. My aluminums are balanced. I have 1 and 1. My hydrogens are not. I have 1 hydrogen on my reactant side, 2 on my product side. So I'm going to add another hydrogen over here. For my fluorines, I have 2 on my reactant side and 3 on my product side. When you have 2 on one side and 3 on the other, the number you want to try to get to is 6 because 2 times 3 is 6. So I'm going to add enough of these HFs to have 6 total. That will get me my 6 fluorines. And then I'll need to add a second molecule over here to get 6 fluorines. Well, when I did that, that messed up the hydrogens that I had already balanced. So I have 6 hydrogens here, 2 more molecules over here will get me 6 hydrogens. When I fixed my fluorines, I also added another aluminum that I had already balanced. So I've got to go back and add another aluminum. So that's what I meant by go back and check your work. Because sometimes when you balance something, you end up messing up something else. So now I'm going to go put my coefficients in. I have 2 aluminums, 6 hydrogen fluorides, 3 aluminum fluorides, and 3 hydrogen gases. So you need to go do your questions and your summaries, and then come see me for your next assignment.